Hello dear students, welcome back. Today we are going to study one more important applications of determinants, that is solving the system of linear equations by using matrix method. This is the second last video of determinants. This type of questions are expected in the examination for 5 marks. Now, the another application of determinants and matrices is an important application of determinant for solving the system of linear equations in 2 or 3 variables. Let me begin with how to find the solution of system of linear equations using inverse of a matrix. Let us express the system of linear equations as matrix equations and solve them using inverse of the coefficient matrix. Consider the system of equations a1x plus b1y plus c1z is equal to d1. The another equation is a2x plus b2y plus c2z is equal to d2. And the third equation is a3x plus b3y plus c3z is equal to d3. These are the three equations with three variables x, y, z with a1, b1, c1, d1, a2, b2, c2, d2 and a3, b3, c3, d3 are the real numbers. To solve this system of equations, that is to find the value of x, y, z, let me express the given linear equations in the matrix form. Let me write the matrix A is equal to, the first row consists of the equation, coefficient of the first equation x, y, z, a1, b1, c1. These are the coefficients of x, y, z of the first equation. Second row is a2, b2, c2 and the third row elements are a3, b3, c3. And another matrix which is known as unknown matrix capital X, which is equal to, is a column matrix containing the variables x, y, z. And the constant matrix B is equal to is also a column matrix containing the elements d1, d2, d3. If I multiply A and X and if I equate with matrix B, we get the first, second and third linear equation. Now then the system of equations can be written as Ax is equal to B. Just now as I told you, the product of A into X is always equal to B. Now this is our matrix A is multiplied with the variable matrix X and that is equated with the constant matrix B. The product of these two is equal to the constant matrix B. We get the three linear equations after multiplication. To find the unknown of x, y, z, we have the case 1. If A is a non-singular matrix, meaning is the determinant of A is not equal to 0, then its inverse exists. The existence of the inverse theorem already we have proved. The inverse of a matrix exists only if A is non-singular, or if A is non-singular matrix, then only the inverse of the matrix exists. If A is non-singular, now Ax is equal to B, or we can write by pre-multiplying by A inverse on both the sides, we get A inverse into Ax is equal to A inverse into B, that is pre-multiplying by A to the power minus 1 on both the sides. By rearranging the left hand side, we get, as we know that the matrix multiplication is associative, then we write this as A inverse A into X is always equal to A inverse into B. This is by associative law. As also we know that A inverse into A is always equal to the identity matrix I into X is equal to A inverse into B. Therefore, any matrix into identity is the same matrix X is equal to A inverse into B, where X is the unknown matrix containing the variables X, Y, Z, and then A inverse into B. As we know how to find the inverse of a square matrix, that is multiplied with the constant matrix B, we get the unknown variables x, y, z. This matrix provides unique solution for the given system of equations, as inverse of a matrix is unique. This method of solving the system of equations is known as the matrix method. Means to obtain the variables x, y, z from the given three linear equations, one should have the equation x is equal to A inverse into B, where B is a constant matrix and we know how to find the inverse of a given matrix A. By using this equation, we are supposed to solve few examples to find or to solve the system of linear equations. Let me begin with the first question, which is a solved question from the textbook. The question in the examination will be given like this. Solve the system of equations by matrix method. The first equation is 3x minus 2y plus 3z is equal to 8. Another equation 2x plus y minus z is equal to 1. And 4x minus 3y plus 2z is equal to 4. These are the three linear equations in three variables x, y, z. Let me arrange these equations in the matrix form. For that, the system of equation can be written as Ax is equal to B, where A is equal to, the first row consists of the coefficients of x, y, z of the first, second and third equations respectively. 3, minus 2, 3, that is in the first row. Second row elements of the first matrix A is 2, 1, minus 1, that is 2, 1, minus 1. And the third row elements are 4, minus 3, 2, 4, minus 3, 2, comma, x is equal to the variable matrix x, y, z as we have seen in the previous theory part. And B is called as a constant matrix containing the parameters 8, 1 and 4. Now to determine the inverse of a matrix, one have to check whether this matrix is singular or non-singular. If the matrix is singular, the inverse of a matrix exists and the solution is consistent and it is unique. Let the determinant of A is equal to, evaluate this determinant or the matrix along the first row. 3 into 1 2s are 2 minus 3 plus minus of minus 2 becomes plus 2 into 2 2s are 4 minus of minus plus 4 and plus 3 into 2 minus 3s are 6 minus 4, that gives minus 6 into minus 4. Therefore, the determinant of matrix A is equal to minus 17, which is not equal to 0, is called a non-singular matrix. Therefore, the inverse of a matrix exists and the solution is unique. Once if you know the determinant of A is non-zero, then one should have to find the cofactor matrix. Hence, the cofactor matrix of the first, second, third row respectively are plus, minus, plus. These are the elements of the minor of the first row, first element, minor of the first row, second element, minor of the first row, third element. And dear students, already in the previous 2-3 lectures already we have seen how to find the minor and cofactor of the given matrix. Now minus, plus, minus, these are the minors of the second row first element, second row second element, second row third element. Again plus, minus, plus, these are the minors of third row first element, third row second element, third row third element. Now after simplification we have the cofactor matrix with the elements minus 1, minus 8, minus 10, minus 5, minus 6, 1, minus 1, 9, 7. To find the adjoint of this matrix, because to find the inverse of a matrix A, one should have the adjoint of a matrix. Adjoint of a matrix is the transpose of a given matrix C. Therefore, the adjoint of A is equal to the first becomes the first column, the second row becomes the second column, and the third row is replaced by what it is? Third column. Therefore, A inverse is given by the formula 1 divided by determinant of A into the matrix. Therefore, this is multiplied with these numbers. Therefore, we have capital X is equal to A inverse into B. Therefore, X is equal to our A inverse is minus of 1 by 17 into matrix adjoint of A into matrix B. Therefore, minus 1 by 17 as it is, by multiplying with the first row first column, first row second column and first row third column, we have the elements minus 8, minus 5, minus 4, minus 64, minus 6 plus 36 and minus 80 plus 1 plus 28. Therefore, this X is nothing but a variable matrix containing the variables X, Y, Z is equal to minus 1 by 17. The simplification of this column matrix will be minus 17, minus 34, minus 51, and minus 1 by 17 is multiplied to all these three elements. We have the numbers 1, 2, 3. Therefore, x is equal to 1, y is equal to 2, and z is equal to 3. Therefore, these three values satisfies the three variables x, y, z of the first, second, and third equation respectively. Dear student, this type of questions will be expected in the examination for 5 marks. These questions are very important for the exam point of view. Let me solve the one more question. This is exercise 4.6, question number 13. Solve the system of linear equations. 2x plus 3y plus 3z is equal to 5. Second linear equation is x minus 2y plus z is equal to minus 4. Another equation is 3x minus y minus 2z is equal to 3. Solve the system of linear equation. Now this system of algebraic equation, let me express into the matrix form. Let A is equal to, the first row elements are 2, 3, 3. Second row elements are 1, minus 2, 1. Third row elements are 3, minus 1, minus 2. Therefore, the variable matrix x, y, z, constant matrix containing the constants 5, minus 4, 3, that is in the column form. Let me check whether this matrix is singular or non-singular. To check the singularity or non-singularity, one should have to find the determinant of a matrix A. Therefore, the determinant of matrix A is equal to, simplifying this matrix along the first row, we get determinant of A is equal to 40, which is non-zero. Therefore, this type of matrix is called a non-singular. Therefore, the inverse of a matrix exists. Once if I know the inverse of a matrix exists, then we find the cofactors of all the elements of a given matrix A. For that, we write plus into minor of the first row first column element, minus into minor of the first row second column element, plus that is the minor of the first row third column element. Similarly, we can find the minor of the second row and also the minor of the third row, multiplying with minus plus minus plus minus plus, that becomes the cofactor of all the elements of a given matrix. Therefore, C matrix stands for the cofactor matrix of a given matrix A. 5, 5, 5, 3 minus 13, 11, 9, 1 minus 7. These are the cofactors, that is, these are the cofactors of a first, second, third row respectively. Now, to get the adjoint of the given matrix A, then we take the transpose of a given matrix. The first row is replaced by the first column, second row is replaced by the second column, and third row is replaced by the third column. We get the adjoint of a given matrix. The transpose of cofactor matrix is called as an adjoint of a matrix A. Once if I get the adjoint of A, then we are supposed to find the inverse of a square matrix. Therefore, the inverse of a square matrix is denoted by the notation A to the power minus 1, and it is 1 divided by determinant of A into the adjoint of a given matrix. Therefore, to find the value of the unknown variable x containing the variables x, y, z of the first, second, and third equation, we have the equation like x is equal to A inverse into B. Now, the capital X is equal to A inverse is our one adjoint divided by determinant of, this is determinant of A, and this is an adjoint of a given matrix into the constant matrix. Therefore, the variable matrix X is nothing but our x, y, z containing the three variables, and this is the inverse of a matrix, and this inverse of a matrix is multiplied with the constant matrix. We have the elements like first row with the first column, we get 25 minus 12 plus 7. Second row with the same column will get 25 plus 52 plus 3. The third row with the same column will get 25 minus 44 minus 21. Therefore, 1 by 40 into, here we have the first row element is 40, second row element is 80, and third row element is minus 40. Now, dividing throughout by 40 to the first, second, and third element of the column matrix, then we have it is 40 divided by 40, 80 divided by 40, and minus 40 divided by 40, that gives minus 1. Therefore, the values of x is 1, y is 2, and z is minus 1. These three values satisfies the given three linear equations x, y, z is called the solution of a given linear equation by this method. These are the very important question for the exam point of view. Students, you practice these questions. For your sake of convenience or for practice, I have given the two questions from the exercise 4.6, question number 12 and question number 14 with their solutions. This is our equation. Question number 12 containing the three equations, and the values for x, y, z are 2y minus 1, z is equal to 1. The another question from the same exercise, that is x minus y plus 2z is equal to 7, 3x plus 4y minus 5z is equal to minus 5, 2x minus y plus 3z is equal to 12. The values of x is 2, y is 1, z is 3. Students, you practice these two problems at home and try to cross-verify your results with the given answers. I hope you have understood these problems in today's class. I hope you have any queries, you can contact with the given below number, or you can WhatsApp to the same number. Thank you. Stay home, stay safe.